Alright, so this question, it's a little different than the last one. Same principle, a little different, because it gave me mass. I started off with mass. So, straight off the bat, I'm going to tell you guys, you can never, never, never compare mass to mass when you're talking about a chemical equation. You always have to go through moles. You can never just compare mass to mass and be like, oh, it's like twice this amount, alright, I'm going to multiply this by 2. No, you have to go through moles first. So, same steps as always. We are first going to get a chemical equation. We got it. Check, they gave it to us. Step 2, we're going to make sure it's balanced. I have carbon, zinc, and oxygen on this side. I have carbon, zinc, and oxygen on this side. I got 1 carbon on this side, 2 zincs, 2 oxygen. 1 carbon on this side, 2 zincs, 2 oxygen. I'm balanced. Boom. Alright, I got an equation and I'm balanced. Now I have to see what they want me to compare. So, excess carbon reacts with this amount of zinc oxide to produce zinc and carbon dioxide. How many grams of carbon dioxide? Okay, so they want me to compare carbon dioxide, and they gave me something about zinc oxide. So they want me to compare zinc oxide to carbon dioxide. Zinc oxide to carbon dioxide. I have to find a ratio. Ratio is next. So for every 2 zinc oxides, I have 1 carbon dioxide. This should be a little 2. Sorry guys. Sometimes that messes up. So for every 2 zinc oxide, I have 1 carbon dioxide. 2 to 1. So if I promise myself that I keep my zinc oxide at the top and I keep my CO2 at the bottom, I could make a fraction, right, where I have 2 zinc oxide for every 1 carbon dioxide is equal to, but then you're like, wait a minute, what do I put here? I have nothing to show here. That is because you still don't have your moles for zinc oxide, right? You only have mass. So you have to go from mass to moles of zinc oxide so that you can solve this little equation here. So what does that mean? That means you have to find the molar mass of zinc oxide. Isn't that fun? So if you look at the periodic table, I'm actually going to cheat a little bit by Googling the mass of zinc. So the mass of zinc on your periodic table should be about 65.38. Oxygen is 15.999. And there's only 1 of each, so I can just go and add those 2 numbers. So on my calculator, I have 65.38 plus 15.999. And I have a total mass of 81.379 grams per mole. Alright, I got the molar mass of zinc oxide. I have a certain grams of zinc oxide. So now I can find the number of moles again to plug it into my little mole ratio equation here. So here we go. I start with 24, can you see that? Yeah, 0.9 grams of zinc oxide. I want to end with moles at the end so I can plug it into my equation. That means that I have to cancel out grams. To do that, I have to put grams at the bottom. Moles are going to be on top. And now I can just plug in my molar mass. So for every 81.379 grams, there is 1 mole. Now my grams are going to cancel out. I'm only going to be left with moles, which is what I want. And now I can just do the math. And that is going to be 24.9 divided by, because it's on top of one another, 81.379. So I have about 0.31 moles of zinc oxide given this mass. So now I can use this information to plug into my ratio. So for every 0.31 moles of zinc oxide, how many CO2 moles do I have? So now I can do my pretty butterfly multiplication here. 1 times 0.31 is just 0.31. And then 2 times x is 2x. Ooh, you can't see that. Let me write it at the bottom. So 1 times 0.31 is 0.31. 2 times x is 2x. So I have to divide both sides by 2. 0.31 divided by 2 is 0.16. 0.16 is equal to x. Alright, here we go. So now I have that my answer, if I start with 0.31 moles of zinc oxide, or 24.9 grams of zinc oxide, I will make 0.16 moles of carbon dioxide of CO2. And now I'm like, yeah, I'm done. I found the moles of carbon dioxide. But I read the question again, and I'm like, how many grams? They want me to know the grams. So I have moles. I need to go to grams. What do I do? Yep, the molar mass. But this time I have to find the molar mass of CO2. So CO2, I got 1 carbon. I got oxygen. Carbon on the periodic table is 12.011. Oxygen is 15.999, but I have 2. So I have to make sure to multiply that by 2. So, here we go. 15.999 times 2 plus 12.011 is 44.009. 44.009 grams per mole. Okay, I'm almost done, guys. All I have to do now is go from moles to mass using the molar mass. So if I start with 0.16 moles, I want to get rid of moles because I need to have grams left over. They want to know grams. So I have to have moles on the top and the bottom so that they can cancel out. That means I have to have grams on top, and then I use my molar mass. I have 44.009 grams per every 1 mole, and all I have to do now is do the math, which is 44.009 times 0.16. And that leaves me with 7.04 grams of CO2. And that is my answer. I found the grams of CO2. So to recap, I know that this one was long. I made sure I had an equation. I made sure that equation was balanced. I used this balanced equation to find the ratios of what they want me to compare. However, I was stumped because it didn't give me my moles of zinc oxide. So this, I had to do a molar mass conversion of mass to moles by finding the molar mass. And then I found the moles that I could put in here. That led me to finding the moles of the other thing that they wanted me to compare, so CO2. And I thought I was done, but nope, because it wanted me to find the mass, the grams, not the moles. So I had to compare this whole answer of moles into grams by finding the molar mass of CO2 and doing my dimensional analysis with molar mass and finding the grams.